Okay, so I'm glad everybody could make it here today. I mean, not everybody's in right now, but those of you who are here, I'm glad to see that you were able to connect. And kind of a new experience for all of us, I think, trying to learn this material through the Collaborate software here. But the good news is that I've got the Robo Guide on a laptop, so I'll be able to do some examples there. And the but I guess before I start off, just can everybody hear me? Is my sound coming through okay? You can just put like yes in the chat, loud and clear. Okay, thank you, Heather. Okay, so I think I've got this recording. I don't know. I just did one of these earlier this morning. It was like 2.5 hours, and I don't think it recorded. So I hope this one records that you can come back and watch it. But I think I figured it out. It's got a little red dot now, so and telling me it's recording. So this will be available later. Before we actually get started in today's material, I just kind of want to review what I posted in the announcement as far as and talk a little bit about how I see this playing out. So the first thing is that we won't be meeting until at least the beginning of April, and depending on how things play out, it could go longer than that. So right now I'm kind of hoping that we are able to get back in the classroom by at least I mean the college said April 1st. I haven't seen anything later than that, but some from what the governor and stuff was saying, it might be a little bit beyond that even. But so let's just say, if we get back, officially this is week 9 of the semester, so we're just starting the second half. So we've still got quite a bit of time. If you kind of remember from looking at the schedule and everything, actually, let me see if I can call up the schedule here. That might help if I get the schedule posted here. Let's see. AIT220. So let me try to post this for you to see. Oh, that wasn't the right one. All right, so let's just look at the schedule here for a little bit and see where we're at. I think for this class, we're pretty well off right now. If we can get back into the classroom sometime in early April. So all right, so let me share this window with you. Nope, that's not it. They they list. Just weird how they list these windows. Got this window open, but I'm not. Photos. I'm not seeing. Oh, there we go, I think. Okay, now I'm not seeing it. Let me post it into PowerPoint and see if it'll work there. Okay, so, all right, so I've got it in PowerPoint now. And so just looking at this schedule here, right, so this is, now apparently I had my dates a little bit off on this schedule here, but where we're at is week 9. I didn't realize the spring break I had kind of out of place here, but looking at week 9, we're talking about some more programming stuff, and actually we talked about the branching before spring break. So today I'm going to talk a little bit more about position registers, and I'm going to talk about inputs and outputs, which I guess I didn't label there, but I'm going to talk about how we can actually turn on or open or shut grippers, or turn on and turn off a vacuum gripper, and we'll talk about I/O in general, inputs and outputs, whether it's robot I/O or if it's digital inputs and outputs, and we'll also discuss, it could be analog, so we'll look at that. We'll look at a few more miscellaneous, and then we'll look at the miscellaneous instructions. I think we looked at most of those, and then we'll look at the macros, and we'll discuss, we kind of mentioned macros, but we'll discuss them in some detail. So looking at the book, we are we covered chapter 15 before spring break, and we talked some about position registers before spring break, which is chapter 17. And we're going to talk about I/O, which is actually, I guess, chapter 14. So we'll talk about, I'm going to talk about chapter 14 today, talk about inputs and outputs, and talk about some details about picking up objects with grippers, and which includes using position registers for offsets. And then we'll talk about macros, and some miscellaneous instructions and stuff. And let's see, so we'll see how far we get through here today on that. And then looking at the but looking at the rest of the schedule, we need to be thinking about our project. If this goes on indefinitely, I'm not quite sure how the project bit will play out, but there is a version of the RoboGuide software that is, there's an evaluation copy of it. So if it looks like this is going to go on, for 6 to 8 weeks, which is going to be kind of the rest of the semester, then one thing that we could do, I can make sure that it's available to you, this evaluation copy of the RoboGuide. Now, this evaluation copy of the software is only good for 30 days. But what I'm kind of thinking is that you could do would be to, do a project in the software, and maybe do a little recording of that or whatever, and then so it would end up maybe being a bit of a scaled down project. But if we so I want to wait, especially since the software is only good for 30 days. I want to wait and see where we're at in early April. But I could say if it looks like we're going to be out for longer than that, then I'll make the software available. If I have to mail it to you, we'll mail it to you. That's fine. But we'll get you the evaluation copy of the software. Runs on Windows machines, and we can do that. So, but as you can see, looking at the schedule, we're pretty much done with the book, and so as I mentioned before, right, pretty much all of April is working on the project. So I think we're in pretty good shape with this class either way. Whatever happens as far as the material goes. So is there any questions that you have before we start talking about inputs and outputs here? I'm going to try to record all lectures. Yes, it's an extra step. And if I forget, because I just forgot the one I did this morning, I didn't realize I thought I had it selected, but there was another spot I had to select it, and I didn't. But yeah, I do plan on trying to record all these next few lectures that we're going to be doing. Okay. And then you'll be able to view them later through Blackboard, or I think they're actually would be available as an MP4 you can just download and then watch offline once you get it downloaded too. So all right, so it looks like we've got 12 people here, so it's just about the entire class. So let me I just want to capture the attendance here. Okay, so today's lecture was supposed to be talking about inputs and outputs. So I'm going to start by going over the slides, and then I'll flip over to the RoboGuide software and do some examples. So, all right, so here's the PowerPoints. Okay, and these are available in the lesson there. And so IO is chapter 14. Okay, and we're going to look at how we're going to look at number one, I guess, kind of really configuring the IO, how to configure the IO, and then how we can use it inside of our teach pendant programs. Okay, and also how we can manually adjust the IO for certain things. So one of the things that we can do, if it's an input, IO is short for inputs and outputs. And so we have a robot. One of the things, if you remember, a robot is effectively like a PLC type device where so you can add or remove inputs and outputs on most of the robots. Now, the robots we have in the classroom are the LR mates, and the LR mates don't really have a lot of flexibility for inputs and outputs. They have a fixed number of digital inputs, and they have a fixed number of digital outputs. They do not do analog at all, so you can't do analog inputs and outputs with the LR mates. But the larger robots are really almost just like a regular PLC. So you can connect on the larger robots, you can actually add more outputs and more inputs as you need. They can be analog or they can be digital in there. So when you have an input, you can do what's called simulate. So you can simulate an input. This allows you to test your program even though the sensor may not actually be picking up something. So you can go in there and you can kind of activate the input and say, yes, it's there, or no, it's not there if it's a digital type input. And then you can run your program using this simulation feature, so you can test the program even though you don't actually have objects triggering the sensors. The other is the outputs. Now the outputs, we can just force those to be on and off. Okay, or we can force the output to be what we need it to be. All right, so let's talk about the I/O types. Okay, and as I'm going along here, I've got the book in front of me, and I'll just try to point out to you some of the things. So if you have your book in front of you, looking at the pages and stuff. So looking at 229, page 229, they just show the different types of controllers, and there's a picture in there for the Model A type controller where, you know, if you're familiar with a PLC, which I know a lot of you are, you know, it looks almost like a PLC where you can just plug in multiple cards into that. So I guess I don't really have the picture available here on the computer, but you can plug those in. So that would be digital I/O or possibly analog I/O cards that you would plug in. Okay, so when we look at the types of I/O, we have the first type I've got listed here, which I'm just trying to find the which page this is at on the book. I don't actually have the page number written down. But, well, I guess it's just looking at chapter 14, starting at page 227. They have the types of I/O there at section 14.3. And they have digital I/O, analog I/O, standard operator panel, group I/O, user operator panel, and robot I/O. Okay, so the looking at these, we see the user operator panel. Basically, what that is a PLC or some HMI type device that you're communicating. You've hooked up to the robot. It could be through an Ethernet connection using Ethernet industrial protocol, or it could be a device net sort of network communication, or a control net. There's a lot of different types of communication methods, but the The user operator panel is an I/O type that is coming effectively from like a PLC or possibly a HMI, HMI standing for human machine interface. Okay. Now, while I'm looking at these PowerPoints, I can't really see if you guys are posting any questions. So every once in a while, I'll flip back and look and just see. So if you have any questions as we're going along, you can post them in your chat. And I'll try to check and look once in a while. Okay. Okay, so I can't seem to find my taskbar. There it is. Okay. All right, so but this user operator panel, UIO, is from a PLC or possibly an HMI type device. Then they have something called the standard operator panel. Now, if you were to go back and look way back in chapter 4, we talked about the robot system, and we talked about these different types of controllers. The standard operator panel is the panel on the is buttons and things that are on the controller itself. So in the classroom, right, our robots, the controller is underneath, so you have to open up the doors and then the controller is in there. Now, the LR mates in the classroom that we have, they don't have any user buttons on them. They're very, very, they're minimal. And actually, most of the newer robots that are coming out are very minimal. If you have older robots, they would sometimes have a couple of buttons. One would be like labeled user 1, and one would be labeled user 2. They may also have like a reset button on them, and a fault light or something like that, and or maybe even a couple extra lights. And so those, if you wanted to like determine if somebody's like pressing the user 1 button, then you would use the SI01 reference to do that. So it, and when we look at the program, it now let me just flip over and show you a program here. Well, okay, so to do this, I have to share it. This is the problem with this. I got to flip back and forth between the two programs. Okay, so if we go over and look at RoboGuide, RoboGuide handling tool. Okay. All right, so if we look at RoboGuide, let me see if I can share just the teach pendant with you. Handling Pro. There we go. All right, so so here is the teach pendant, okay? And so if I click on the IO button, so down here, right, is the IO button. Now, if I click on the IO button, they give us some cell outputs, and it depends on the robots. Some of the newer robots actually have some others, but we were just talking about the different types of IO. And so one of the types of IO, which is a newer one, which your book isn't addressing, is called cell interface. I/O. So this would be like various sensors, usually safety sort of stuff, hooked up to the cell, the work cell itself. Okay, and then another option is custom under here. And then we have, as we've already discussed, we have the standard operator panel down here at 8. That's what we're kind of discussing right now. We have the user operator panel, which is the PLC or HMI, and then the robot, the group, the analog, and the digital. We'll come back to all those. All right, so but right now I was talking about like the standard operator panel. So what you see here is these are outputs. So you might have like an LED or two or some sort of indicator light on your robot, and so these would be that I/O. If you notice when you're on an I/O screen, F3 here in the middle will toggle you between inputs and outputs, because every type of object, whether it's robot I/O, digital I/O, analog I/O, PLCs, the UIO, or the standard operator panel, you have an I and an O, an input and an output. So each one of these screens will have an input and an output on them. Now, so as I toggle between here, what you notice is F2, this right here, rectangle, is just blank. However, if I go to something like digital I/O, there's a configure option. Okay, but when we go to the standard operator panel, you can't, there's nothing to configure. It either has that I/O or it doesn't. And most of the newer robots, they're not putting really any usable type of I/O on there. They don't have user buttons. They might have a cycle start button, but they don't have, or they do. I mean, now every robot obviously has a cycle start on the controller. Okay, so that is there, but they don't have like a user push button 1 and push button 2 on there, because it costs money, obviously, to put that in there. And the reason they don't bother with it on newer robots is because I have not seen a new work cell go in for years that doesn't have an HMI interface already attached. And so, and what they're doing, they're like, why should we spend money on putting buttons on here when people are just going to use the HMI anyhow? So it's not that they're really trying to be cheap, but it's like, we're putting money here where it really doesn't make sense anymore, because pretty much any new work cell is going to have an HMI kind of interface close by, and so they figure they're just going to program it through the UOP sort of connections. Okay, so those are the UOPs. And the SOPs. Okay, so the other types of inputs are digital. Okay, so you can have digital inputs and you can have digital outputs. Digitals are either on or off, right? That's all there is. It's just a 1 or a 0, true, false, on or off. So now this is the configuration screen. So I got here by pressing the I/O button. Now, when we talk about macros, the I/O button, this I/O button could be reprogrammed to do something else, and so we couldn't get there. But you can always go to menu, and then under menu, you'll see I/O. And if you just select that screen, then it'll take you to the I/O. And then you can always select which one you want. You want to talk about digital I/O or whatever. So this is digital output. And so if we look at, F3 is going to connect us to, or flip us to the input screen or the output screen. All right. So now you notice here on the inputs, there's a simulate, SIM, simulate. And so, as I mentioned before, we can come over here and we can simulate a input. And so by simulating it, we can force it basically to be on. All right. And is basically what you're doing here. So you're simulating it, you're turning it on, saying that there's something there. It's digital. So it's like a proximity sensor or something says, you know, something's coming down the conveyor, and then it senses that yes, it's there, and it turns on, or it's just off. Okay, so these can be simulated. Okay, and if you, let's say you're testing and you're using lots and lots of inputs, so you may have 10 or 12 or 50 turned on. Well, you can unsimulate all of them or turn them all back to off by hitting the function button down here and then going to the next screen and say unsimulate all. So let's just take a look here. I'm going to simulate this one and simulate this one, and then come to function, next, unsimulate all, and it'll reset them all. So the purpose again of the simulate is the fact that we just want to test our program, and we don't actually have parts moving down the conveyor tripping the sensors, so we can force them to be on by selecting simulate. On the other hand, if we look at output, the outputs, we can just come and boom, we can turn it on or turn it off. Okay, and so we can force inputs, or not inputs, but we can force outputs to go on or off right on the fly like this. Okay, and you can actually do this whether you're in auto mode or you're in teach mode. It doesn't matter. You can just come in and force it on or off. Okay, so that's how you do that. Another thing to mention here, remember the item button. Okay, so if I was on the robot in the classroom, robot 1, which I'm usually use it for examples instead of the robo guide here, the first digital input is 101, or the first digital output is 101 for that matter. And so remember, if we can click item, and if we know we need to go to 101, I can just then come over here, type in 101 and hit enter, and it immediately takes me to that robot or that input or output. Okay, the other thing is, notice over here there is you can put comments in here. So you can label these. Okay, you can come in here if you hit your next key, right? You come over to detail, and you can look at your detail of a digital input or a digital output, and you can put in a comment here, right? So we can just kind of hit enter, and we can label this. This is a digital output. Okay, hold on just a second. There's a digital output. You know, we can label this output or input or whatever to be whatever it is. So we can just come in here and say, you know, this turns on the conveyor 1 or something like that, and we can you know, so we can label these so that when we're on the screen, or when we're on the main screen, it'll be labeled. Okay. The other thing is, if you look here, you can toggle between the config. Okay, so here is my digital outputs, and these outputs we can tie to a rack or a slot. Okay, and so what that means is, let me grab a picture here. and throw into the PowerPoint. I don't know why I don't have any in there, but didn't copy. All right, so I'll flip you guys back over to the PowerPoint for a second. Okay, so here's the PowerPoint, and this is just showing this is one of the I/O racks for the robots. So on the larger robots, we can actually each one of these different cards or different modules here. You see the little black spots over here at the edge. I can plug in 3 more cards. So one of these cards might be a digital input, and this may be a digital output, and then this could be an analog input and another analog input and a digital output or analog output or whatever. So each one of these cards can be various I/O. Now, so the whole thing is called a rack. Okay, so the whole piece is called a rack, and then so this whole thing is called a rack, and then you have slot 1, slot 2, slot 3, slot 4, and then if it's a rack, or if it's a card, if it's a digital card, you see it's got terminals you're going to wire up to the sensors here. And so each one of these terminals then, it represents a bit inside the computer that you're going to turn on. So when we look at the configuration of the robot, okay, so this is our configuration screen, and what you're doing is let's say that one of these cards over here, let's say this first card is a 16-bit card. Okay, so if this first card was a 16-bit card, then what you would do is say rack 0, which is the first rack there, slot 1, which is the first card, and then bit 1, so I would put like a start at 1, so bit 1 would be bit 1, so this would be 1 through 8 would go from 1 to 8, and then the second half would be 9 through 16, so it would be rack 0, slot 1, and then it would be starting at 9. And so you can configure, you're configuring where the actual I/O is wired out of the cards into numbers that you'll use inside your program. Okay, so now if we go inside of a program and I wanted to use digital input like 101 or whatever. Okay, so if you look here, like here's 65 through 104, and those are in slot 3. Okay, and starting at 1. But let's say we're do digital out 105 here, because that, okay, so digital out 105 starts at slot 4. So it's rack 0, so the first rack, which counts at 0, but slots start counting at 1. They don't count at 0. So rack, but this is slot 4, rack 0, slot 4, bit 1 is digital out 105. And so if I wanted to use this in my program, I would switch back to the Robo Guide. Okay. All right, so if I'm going to use this inside the Teach Pendant program, I'm going to come here and remember the next, and we go to instruction, and then under instruction you see IO. Now notice here, if you look at your IO, your choices are digital out, DO, RO for robot out, GO for group output, we'll talk about later, AO for analog output, or I can take inputs like digital input and put the input into a register. Okay, and then we, you know, so we only have like digital out and robot out and a group output here. And so you have to do the configuration on there. All right, so we have to record these configurations. So now if we come in here then, I'm going to do digital out. So I'm going to select this digital out. Okay. And why is it not selecting? Oh, my Teach Pendant's disabled, right? Remember to read your error messages up here, right? So you can't modify a program if your Teach Pendant is shut off. And RoboGuide always has your Teach Pendant shut off. So, all right, so now I can select this and I can add this. And then let's say we were going to do, it was digital out 105. So we'll put in a 105 here. And then we can either turn this on or off. Or if we wanted to, we could set it to a pulse, which would just turn it on for like so many milliseconds or something. So, or seconds. So you could do like, you know, 1 second or something like that, or you could do like 0.5 seconds, so half a second. So if you do a pulse, it'll just boom, it'll come on for half a second and shut back off. But if you wanted, you know, if you remember, there's always choice there, so you can just force it on. So we're going to turn it on, and then later we could come back and turn it off. Okay, so that's how you do a digital output, okay, or a robot output. The difference on the outputs, if we go back to our I/O menu, okay, and we look at the different inputs. So we have digital inputs and robot inputs. Robot inputs are digital, but they're connected to the arm of the robot. So if you remember on the robot, right on the arm past joint 4, there's a connector there. There's an electrical connector there, and then there's also the air hose connectors there. Okay, so those air hose connectors inside of the arm are digital solenoids you can turn on and off to turn the air on and off. Those are robot I/O. Okay, so notice there's only 8 robot outputs and 8 robot inputs. So in that, on that robot arm, you have the possibility of 8 inputs, digital inputs, and 8 digital outputs. Okay, so the digital, they're digital, but they're connected to the arm, so officially they're robot inputs and robot outputs. So they're digital, but they're available right at the arm near joint 5. They're between joints 4 and 5 on the robot. And so you don't have to run a cable all the way up to the robot. You just run them from the arm there between joints 4 and 5 on the robot out to the actual gripper. So the inputs obviously could be used for like some kind of sensor to detect that you know, like just say you got a gripper. Some grippers are what I kind of refer to as a smart gripper. So if you grab something, they can sense that yes, you actually grabbed it, and it instead of you grab thin air and it didn't actually get anything. And so you could use a robot input sensor to sense that yes, you actually had something. All right. So, but when you look at programming them, the difference is this is a digital output. If you wanted to like use a robot output to turn on a gripper, then you could come over here and you would just come down to robot output and turn. You'd have to select which one you want. Robot output 1, 2, 3. Remember, there's only 8 robot outputs, and then turn it on. Okay, and that would turn on that would activate that robot output. Okay, so it looks exactly the same except for, you know, DO is digital output, RO is a robot output. So they're both digital, but the robot outputs are on that little section of the robot arm between joints 4 and 5. Okay. So it used to be on robot 1 in the classroom. We had our vacuum gripper was actually on digital out 101. It wasn't actually through the robot output. Okay, but now if we ever get back into the classroom here, we'll be using the outputs just on the robot. So it'll be like robot out. It might be robot out 1, might be robot out 2, might be robot out 3. It just depends on where you connected your air hose. Okay. Any questions so far? Everybody okay? All right, so let's go back and look at the configuration screen here. So there's the main, again, this is the robot screen, and there's nothing to configure on robots' inputs and outputs. You've got 8 of them, and they are what they are. I mean, you can simulate them, you can force them on and off, but there's no configuration. So F2 here is just grayed out. But if I go to the digital, I have this configure option where I can set it to be a rack, a slot, and then a starting point on there. So I can put those in. The other aspect is that if I'm doing something like Ethernet IP, and this, I'm pretty sure I had this in the slides here. Yeah, okay, so slide 11. Let me flip back to the slides here. So looking at slide 11, okay, at the I/O assignments, okay, so if it's a physical rack, you know, like the one I kind of showed you here in this picture, if it's a physical rack, then it starts, the very first rack would be rack 0. The very first card in the rack would be slot 1. But you can, on the big robots, you can actually add a second rack or possibly a third or fourth or fifth rack in those larger robots. All right. And so when we look at the configuration up here at slide 10, and we look at this configuration, we see that you know, if it's just a physical rack, it starts counting. But if you're using a network sort of communication protocol, they have other racks are dedicated. So some of those racks, DeviceNet uses various nodes, and so the FANUC robot will support up to 4 different nodes. And so the first node would be rack 81, the second rack 82 up to 84. If you're using Ethernet IP, which I know some of you have discussed using Ethernet IP for your projects, and if you're doing that, you would have to configure it to be rack 89. So if we were in the classroom, I could show you robot number 4 has Ethernet IP set up for it. And so that what we have to do is we come in and into our configuration here, and we say rack 89. So we can actually, boom, pop in rack 89 here, and then tell it which slot, and tell it how many starting bits, or what the starting bits here. And notice here it says pending. And so then what we would have to do after we make this change is we'll have to actually restart the robot. So I'll have to like flip over here to the robot, and you can't really see me doing this, but I'm just going to flip over here to the robot and restart it. And I don't know what's going to happen on the screen when I restart this, but I'm just going to restart the controller. I may have to reconnect it so you can see it there. Oh, I'm still on PowerPoint, so I guess you didn't see that. I'll have to do it again. Okay, so handling tool. No, wrong one. Okay, I gotta flip through screens like mad here. Okay, so we're going back. Come on, screen, flip. All right, so there we go. All right, so if I'm back on the teach pendant, and I'm going to go back to my I/O menu, I/O, and I was under digital I/O and I was under config, and I changed that to rack 89. So I just come in here and I change this to whatever rack that I want it to be, rack 89 or rack whatever. And so if let's say I go to the input, and I'm going to do the same thing for my inputs. I'm going to come over here and I'm going to go from, say, 65 to let's say I'm only going to do 4 bits, so I do 69. And then I'm going to put in rack 89, which is Ethernet IP, and it's going to be slot 1 and bit 1, and then it says pending. So there you can see that pending. And then when I restart the controller, so if I then go and restart the controller, it will show up as active like the rest of these do. So anytime you make a change of your I/O configuration, you got to come back in and restart the robot for that change to be applied. Okay, so going back to our PowerPoint to just see the choices and things there. So we're all right. So just looking at that. So if you're using Ethernet IP, that would be rack 88. If you're using Profibus, it would be either rack 66 or 67. So these rack settings here are configurations based on what type of communications you're using. The mate controllers that we have in the classroom, they have like an internal I/O. They only have like, it's like, I don't know, 24 inputs and 28 outputs or vice versa or something like that. So they only have very limited I/O. But that I/O shows up as rack 48. So again, if I was in the classroom with the LR Mate thing and I would look at the config screen, you would see the digital I/O would be assigned to rack 48. Okay, so so that is those I/O assignments. So when you look under the configuration, that is there, and it's pretty easy to configure. But once it's configured, you don't need to go into that screen unless you add some new I/O of some sort. All right, so so we've got the digital inputs and digital outputs. Okay, and here it is. I have it in the slides here as far as the R30IB mate controller. 28 inputs. I thought I said that backwards. 28 inputs, 24 outputs on rack 48. So those are the robots we have in the classroom. They only have digital inputs and digital outputs. They do not have any analog. But the larger robots can have analog also. All right, so analog outputs, you pretty much reference the same way, only you use either AI for an input or AO for an output. And the thing is that analog means that what it's going to do is read a voltage. So you're basically, an analog input's kind of like a voltmeter. So you're hooking up two wires to a circuit, okay, which would be an analog sensor. And that analog sensor, what's that? Did somebody say something? Just kind of cut through here. All right, so but the analog inputs are a number. See, digital is just on or off. Okay, whether it's an input or output, if it's digital, it's either on or off. But analogs are going to be a number. All right, so they're going to just be some value in there. So it could be, 1.6, it could be 3.1415. It's going to be some kind of number in the analog inputs. All right, now group I/O is kind of a different animal. It's kind of a cross between digital and analog. What you do with group I/O is you take digital inputs and join them together. Now, for this to work, they must be adjacent, so they must be lined up. Let's say we were talking about digital input 101 in the classroom. Well, you can take digital 101, 102, 103, 104, and you can put them all together. Okay, so digital inputs are just an on and off, but if you group them, then you can send in like multiple signals. So you can send in, like if you group 3 bits together, then you have 2 to the 3rd possibilities, because each one of those 3 digital inputs could be either on or off. And then that would give you 8 unique possibilities of values 0 through 7. Okay, so those are digital. So if we configure, you go into your configure and you tell it, let me throw the screen on here. I'll do a snap shot. So menu, IO, group, okay, config. And so rack 48, slot 1, all right, so snipping tool. All right, so here is the group output and configuration. So I'm under the configuration piece. So this is rack 48, slot 1, start 1. So that's the first bit is bit 1, and I'm going to use 3 bits. Okay, so that is my group IO. So now if I click on the monitor, this will be a value okay. So if I go back to monitor, you can see here it says like group output 1, and then the value would actually show right here. Okay, so
Dr. Hartman, the PowerPoint's still up, not the teach pendant.
yeah, I was pasting into the PowerPoint though. You're not seeing that? It's like not updating. Huh, I took some snapshots and posted into the PowerPoint, but it seems like it didn't update for some reason. Let me reshare it. Okay, lecture, allow. Okay, well, I'll switch back to the teach pendant then. Yeah, I was trying to paste them into the PowerPoint, but it seems like it doesn't want to update. So let's go back to the teach pendant. Thanks for, yeah. The problem is when I'm trying to do this, I can't see anything when you put in the chat window. I can't see it because I have the other screen up, and I only have one screen on this computer. So next time I do this, I might try to hook up a external screen to this laptop so I can kind of monitor your chat questions there. But okay, so you guys see the teach pendant now, right? Yeah. Okay, so the if we go to configure, back to the configure because you didn't see this bit. So I go to the configure, and when you do the configure, you actually have to tie it to the rack. So technically, like rack 48 is actually still tied to a digital output also, but so I'm tying it both to digital output and to into a group. And so I'm telling it rack 48, which again, this would be for an LR mate robot. Rack 48, slot 1, because they only have slot 1, and then you pick which one of the inputs you want to start your IO with. Or this is output. This is a group output. So I'm grouping 3 bits. Okay, and then like if I went to monitor and if I had if I monitored, then I could actually force, well, this is an output, so I could force the a value in for that. Okay, now it's giving me port not defined because this isn't an LR mate robot, and I put that in there. So if I went back and put in a rack of rack 1, it would probably let me do that. But I'm got to power on and off for that to take effect. Okay, so you see the message there. But so the group outputs and inputs are just going to be, they're going to be a number, but they're going to be an integer number. And that number could be 0 up to however many bits you have. So if you have 3 bits, you could have 0 through 7. If you had 4 bits, you would have 0 through 15, and so on. Okay. So the group outputs are kind of nice. I know a couple of students were talking about doing their project using an Arduino to read in some values, and then you can send that. With group inputs and outputs, you can send like 8. If you do 3 bits, you could do 8 possibilities with just 3 bits. So like your Arduino, you would have to just send 3 outputs of either on or off, and that gives you 8 possible bits of information that you can use. Okay, so when we go back to edit, this takes us into our program. Okay, and so with a group output, if I wanted to do a group output, I would go to instruction and IO, and then I would do a group output. Now, group output can be a number. It's not going to be on and off. It can actually just be a number. So that number there, we could do group output 1 or whatever group. But then now this could be a constant, right? And so I could, now it's really got to be an integer though. So I could put in like, you know, 5 or something. Okay. So now if I flip back to my IO screen and look at this, well, we don't see it right now. Actually, I think I'm going to have to restart for this to happen again. Let me go back to restart. Okay. And of course, you lost the teach pendant because I'm restarting the controller here. Okay, so I think I'll share it again so you can see it. Okay, all right, so we're back up and running here. So I restarted that configuration. So we're going to go to IO, group IO. All right, so now you can see that group output has a value of 0. All right, because I went into the config and I configured it for rack 1, slot 1, bit 1, and now it's got a value of 0. Okay, however, if I come along and I run this program, so if I run line 1, or excuse me, line 4, which says group output 1 is equal to 5, and then I pop back to my IO, now it's 5. Okay, so I can, you know, so digital out and robot out are just either on or off. They're digital. But group outputs are integer values of multiple bits grouped together. And group inputs are the exact same way. All right. So, but this is how we can set outputs. Any questions about setting outputs in the program? This is, so with, you know, we're just running through a program and it's just going to set those. Okay. So So let me check the chat if you just want to put something in chat there. Okay. Or, all right, so inputs is data coming in. So if we look at our instructions, okay, so if we look at our instructions here for inputs, what we can do for inputs is we're basically going to take them and store them into a register. All right, so this is a data register. Okay, and since it's a digital input is either on or off. So when the digital input is on, it will take this, whatever digital input 1 is, if it's on, it's going to store that into register 1, but in register 1 it's a number, so it'll show up as a 1, not an on. Does that make sense to everybody? So a digital input will, if it's on, it'll put a 1 in this register. If it's a off, if the digital input is off, then it'll put a 0 in the register. Okay, so then we can use something like an if statement, and I can say if, okay, and actually inside the if statement you can reference the digital input directly if you wanted to. Okay, so but in this case I already did line 5, and so now I'm going to say line 5 said digital input, whatever that was, either on or off, puts a 1 or a 0 into here. So then I'm going to take this register and I'm going to say, well, if this is equal to a 1, then I'm going to call such and such a program. Okay, so so if register 1 is 1, call the home IO program, whatever that program is. All right. Now, I want to make a huge point here. Think about a conveyor belt. You've got parts moving down the line. And this is a program that is running. Okay. This line 5 only gets executed every so often. And so you've got a part moving down the line, and it triggers in digital input 101, and that digital input becomes a 1. However, this line 5, if line 5 is executed when digital input is on, then register 1 will become 1. And so therefore line 6 will be true, and the call home IO program gets executed. However, if the part moves on past, before or after line 1 is executed, then register 1 is a 0. And so therefore line 6 would be false, and call home IO would never be executed. Right? So you got to keep in mind that this is a program that is being executed, and you know, like line 1 is a motion instruction, so it's moving the arm from wherever the arm is at over to point 1, wherever that is, and that takes time. So if this part moves down the line, triggers the sensor, and then moves on down the line, so the sensor goes back to 0 before it gets to line 5, then register 1 is going to be a 0, and line 6 will be false, and we're never going to execute the home program. Okay, so you got to keep in mind here that these lines are going to only be triggered and set these values at certain times that it's actually executing the code. Okay. So does anybody have any questions with that? Okay, I don't see anything popping up there. So, all right. So all right. So we can just, this is how we would just set outputs. Okay, outputs, we just set them. Inputs are coming in. We can either store them inside of a register and reference them later, which I'm doing between lines 5 and 6. Or in the if statement, I can just say at the time, I can ask a question, I can come to choice here, and I can say, is digital input 101 on? Okay, and then if that was the case, then I don't need line 5 if I do it that way. Okay, so you can do it either way, but inputs, you're basically just looking, you're going to use an if statement or something to look and say, is this input on? Okay, if it's an analog input, you can maybe use it to add to a value. So if we kind of look at instructions here, and I can say, let's say that register 1, oops, not position register, sorry. If register 7 is equal, is, I don't know, equal to 5 plus, and then we could actually add, I mean, you can add a digital input too, but you could add the analog input, if I can see it here. Here it is. So analog input, whatever. All right, so in this case, what I'm doing is I'm taking whatever analog input is, and I'm adding 5 to it and storing that in register 7. Okay, so so if analog input, for instance, was a a voltage, and we're just adding a little bit more to it, and then we're putting that in register 7. And then I don't know, if we wanted to, then we could send that back out as an analog output. We could send out to output 2, and we could send out register 7. I don't know. So they're just trying to show you some different ways that we can use digital inputs and digital outputs. Okay. Now another thing we can do though with digital inputs, for instance, is we can use a wait statement. We've talked some about wait statements, but one of the choices with wait statements here is we can wait for possibly a digital input to become a 1. So we could look and say, okay, well, digital input 1 is on. And so in this case, we're just going to wait and wait and wait. And this program will not move until that digital input goes on. So we'll be stuck at this program. The program would be running, but it's not going to move to any other line until this goes on. Now there is a choice here to add a timeout. And then the timeout, if and timeout is a variable, you would have to set the variable. Timeout might be 1 second or 60 seconds, a whole minute or something like that. You'd have to go into the variables to set the timeout. But then you could jump to a label. If it never turns on, you could jump to some other location in the program. All right, I'm just going to flip through the PowerPoints here real quick to see if there's any major points that I wanted to point out, and then I'll talk about the code. Oh, okay, yeah, there is one couple of things I need to talk about here yet. Okay, so if we go back to the I/O screen, okay, I'm going to go to the digital I/O, and I'm going to go to over here to the next. Ooh, what happened there? Okay. All right, so I'm going to go on the digital output screen, and I'm going to click on the next over here, and I'm going to go to detail. I already talked about the comment, but there's two other things I want to mention here on this screen. One is the polarity. Okay, the polarity can either be normal or inverse. All right, and the thing there is that your sensor, and sensors, a lot of times sensors can be switched back and forth. So, and if you've had PLC class, which I know a lot of you have, but maybe some of you haven't, but you have with various digital sensors, they can either be active when the part is there. They can be putting out a 1 or an on or true, however you want to look at it, or excuse me, or they can be off when the part is there. All right, and so you can have in PLC talk, usually they refer to either normally open or normally closed. Same type of thing. Well, the thing is that you wire a switch or set a proximity to be normally open, normally closed, on when it's there, or off when the part is there in front of it, however you want to think about it. And let's say that you wire it wrong, and you really wanted the opposite. Well, you could either go back and rewire it, or you can just come in here to the configuration and say, hey, when the sensor says it's off, turn it on, and vice versa. So that's what this normal or inverse will do. Now, if you change that, you're going to have to reboot. So I'm not going to change it. The other thing is this complementary. Okay, with the complementary, the same thing. The complementary can be true or false. Okay, but what that basically means is that notice it only works with the adjacent I/O. So this is digital input 1. And if you set it complementary, what that does is if you force, this is an output. So if you force the output on, it'll automatically, if you force output 1 on, I'm digital input, okay, I'm going to input 1. And if I forced it on, so like if we looked at the program inside the program, I said, digital input 1 is on, then if this is true here and under complementary, it would automatically force 2 to go off. So you don't have to manually say, okay, I turn 1 on, turn 2 off. Now this is one place where this is definitely needed is with finger grippers. So if you remember, I'm sure one time I passed around those finger grippers, and the finger gripper has 2 air hoses that connect to it. And one of them pushes the grippers open. So when air's pushing through that hole, it pushes those grippers apart and opens them. And then the other air hose pushes them together, forces them to slide together. Now think, if both of them were pushing air at the same time, the gripper wouldn't know whether it's supposed to be opening or shutting. They'd be fighting each other. So this complementary here is a setting that's definitely, if for nothing else, is needed for those types of grippers that use 2 air hoses. So you turn the air on for 1, and you need to make sure you shut it off. So this will shut it off automatically, so you don't have to manually program it to turn on the one gripper and turn off the other. It just, boom, does it. All right, so so that's the polarity and the complementary piece. We can come in and configure those. Now again, if you make a change here, you're going to have to restart the controller for it to take effect. All right. The nice thing about having this teach pendant shared for me is I can actually see your screen. So if you have a question, you want to just type it in the chat, I'll be able to see it right now while I'm working in the teach pendant screen. Okay. All right. So the other thing that I want to talk about with the IO screen here is if we so we go back to the main screen and we hit type, there's an interconnect. I really love this interconnect. It's kind of cool. So with this interconnect, you can take and tie an input somewhere automatically to an output. So what we can do here is this is a robot input, which forces an output. But if you hit select, we can take a digital input to force a robot output, or a digital input to force a digital output, or an SI, which is the panel input to a digital output, okay, or the ES there. But so normally we just like do either digital input to robot out or digital input to digital output or something. But what I can do here is I can say, hey, if digital input is 101, okay, so if digital input 101 is on, that will force digital output 1 to be on. All right, and this interconnect piece here is an immediate thing that if that sensor senses something on digital input 101, it immediately activates this output. Okay, so this is cool. For nothing else, then we can use it for the lights. So as soon as the sensor detects something, it could turn on a light and just alert you that it's there. Okay, but this is an immediate interconnection here. As opposed to in the program. All right, so the interconnect is just, it's kind of cool that you can do that. At times it's kind of nice. Not, you know, obviously like a lot of things, you don't have to use it, but it's there and available if it's convenient for you. All right, so the other thing that I want to kind of talk about is now, how do we pick something up? Okay, so we've talked about using this input and this output. So the question becomes now, how do we grab and pick something up? So I've kind of talked about this a little bit last week before spring break, okay, but I want to go over it again to hopefully make sure that you understand all the different implications of this. So I'm going to switch back to the PowerPoints. Hello. Yeah, I know. Let's see. It's not popping up the window to let me change back to the PowerPoint here. on here. Okay, yes, I was silent. I had to reload because the browser wasn't allowing me to update the application, and then when I reloaded, it set the microphone off. So thank you. Okay, so hopefully everybody can hear me again now. It's showing green, so I believe I'm good. All right, so anyhow, so talking about the payload here. Okay, so the payload is you have to go into the payload schedules under the motion instruction under setup. We talked about that earlier to set the payload, but the payload has like the mass, the center of gravity, and the moments of inertia. So if you're picking up a heavy load, and especially if you don't have it perfectly centered, then there's a payload piece in here. So it uses this payload to calculate how fast it should accelerate, number one, but also the servo motors all have force sensors in them. So if you the force sensor is used to detect if the robot runs into something so it can stop. And so the payload is if the payload's not set correctly, it may not detect if it runs into something, or it could give a false error because if your moment of inertias are off and you're kind of swinging around a big heavy object and it doesn't know where the proper moment of inertia is, it'll affect and it could cause a false trigger of your sensor. So what we have to do is we have to set our payload. So if I'm going to pick something up, first thing I really need to do is I need to have a payload of just the gripper, because some of those grippers can be very heavy, and usually they typically will have a pretty good center of gravity, but they still have crazy moments of inertia. So you need to set that in the payload schedule, and then here you just select which payload. So I'm going to say like payload 1 is just my gripper. Okay, so we set that. And then we're going, so that should just be set at the top of your program. So remember, at the top of your program, you should initialize, should have kind of an initialization section. So here I'm going to set my payload, and then I'm going to use offsets. To pick something up, you really need to use an offset. So I'm going to use my offset here. And so the first thing I have to do for my offset is I have to select a position register that's going to be how much I'm going to offset. And you got to zero this out. I talked about this before spring break there. You've got to zero this out. And this is just mine. You're not going to find this in the book, I don't think. This was just my method of zeroing out your position register. So if you take this LPOS, remember your LPOS, it has your X, Y, Z, yaw. We usually use W for yaw, pitch, and roll. All right. And so all these values need to be zeroed. And so if you take this, whatever your current position is, so your current position might be like, I don't know, 175, 45 degrees, 99 degrees, 344 degrees. Okay. So this might be your current position register, but you're subtracting these. So you're taking 1 minus 1, 7 minus 7, 5 minus 5, 45 minus 45, and so on. And so you end up with having a 0. So you end up zeroing this out, okay? Because you're going to go to a point number 2, to pick something up. And then you're going to be offsetting of that. So the first thing you got to do is make sure your X's and your Y's and your yaws and your pitches and rolls are what they should be. Then what you're going to do here is your third position, which is the Z position. We're going to put in a minus 50. Now, the reason we do this, the negative sign, is because I'm using a tool offset. The tool offset is offsetting based on the tool frame. And remember, plus Z in the tool frame is straight into your part, unless you redefined it using a 6-point method. But typically, plus Z is going to go straight down into the part. So we're doing a minus 50. You could also choose just a straight offset, so if it doesn't say tool offset, it would say just offset here. Okay, straight offset, as you see, hopefully you guys are seeing these changes I'm making. It doesn't look to me like it's updating. Is it not updating my changes? Oh, okay. Shoot. I don't know why it's not updating that. Man. That's annoying. Yeah, I've been making changes here as I'm talking, and it's not showing any of these. So let me try a different app. Okay, PowerPoint is, oh, I see what you're saying. Yeah, I guess I need to save it. It's allowing me to change, but it's not updating it for you. We'll see if that'll work. It's still not updating on your screen for some reason. Let me try a different technique here. Okay, let me try sharing this. All right, so let me see if this will work with me here. Okay, so this LPause minus LPause, yeah, so you guys can see as I'm moving things on this screen. PowerPoint, I did take it out of read-only mode, and it still didn't seem to update, though, so I'm not sure what it... Okay, so, you know, your position register has a yaw, pitch, and a roll. XYZ, yaw, pitch, and a roll. So what we're doing is the Z is the third one right here. Okay, so the Z is the third one. So the first thing we do, this first line, okay, so this first, or it's actually the second line, the line after payload, takes an L pause minus L pause. So it's subtracting whatever the values of the current position are, it's subtracting them. And then what we're doing on the following line is we're taking right here on this line, we're taking this minus 50 here and putting it in the Z position. Okay, and so if you're doing a tool offset minus Z, minus Z is going to be straight out from the pointer, from the tool center point, right? That tool center point that we taught in our tool frame. I'm trying to use my hand here, but I guess I don't have my camera on either. Okay, so that tool frame, so it's coming right right out of that. So it doesn't matter if it's at an angle or straight up and down or whatever. So that's why I like to use the tool offset when you're trying to pick something up, because whichever direction your pointer is pointing, that minus Z is straight out from that. So notice when I pick this up, I have multiple lines here. Let me get back to that app. Okay, so all right, so right here on this line, I'm going to pick up, I've got 0.2, which is a pickup point, and I'm going to be offset. And again, it doesn't matter which direction that gripper is pointing or whatever, but I'm going to be offset above that using this minus 50. I'll be 50 millimeters above that. Okay. If I used straight offset, that would be based on the user frame, and I would have to put a plus 50 there instead of the minus 50. But the problem with user frame is depending on what you're trying to pick up and how you're going at it, you would have to have the user frame taut to match that, or you may not be coming straight in. So when you're trying to pick something up, you really need to come straight into that part and pick it up. So notice here, this is an offset point, and I'm using a joint to get to it. So notice the motion type is joint here. Okay, so I have this joint motion type. So because I'm just coming into this point above it, I haven't got to it yet. But then the next thing, the next motion type is a linear, which is going to come straight in to 0.2. So 0.2 is where the object is that I want to pick up. So I want to come straight into that point. So I'm doing a linear movement. And also notice I'm going to stop, because I'm going to have to pick it up. So you're going to have to stop. So I'm going to come in and I'm going to pick it up. I'm doing a fine, so I'm coming straight into that part. Okay, now if let's say that I have some object here, my coffee cup, you can't go wrong with a coffee cup. So here's my coffee cup. Say I wanted to come in with my gripper and say grab the top of my coffee cup to take it off or something like that, right? So I want to be, my gripper has got to come straight down. Not sure how well you guys can see this. I'm trying to, okay? So, it doesn't matter where the gripper, which way the coffee cup is pointing, but my gripper needs to come straight over this. If it's coming in at an angle, it's not going to be able to go straight in. So that's where this tool offset is perfect for picking it up, because it doesn't matter how the object you're picking up is oriented, because your offset is minus Z straight out from where. So you get your gripper oriented, and then you come straight in, and then close your fingers around it, and then come straight back out, because you might be, you're pulling this out of a holder or something, and so you need to come straight back out. And so that's what we're doing here, is we're coming straight down, linear. We're going to stop. We're going to turn on our gripper. We are going to turn on the gripper. And then, as I believe I mentioned before, right, your grippers take a little bit of time to close or activate. Even if it's a vacuum gripper, there's a delay. So I usually use about 0.2 seconds for the grippers we have in the classroom. One whole second is a really long time when you're sitting there waiting for a program to run. And if you bring it over there and it comes over and it comes down, and then you got 1001, you close, and 1001 before you start moving again. One whole second. You think, a second, that's not that long, but it's longer than you need to wait. So I usually do about 0.2 seconds. It depends on your gripper. But so again, we moved into position up above our cup or whatever object we're going to pick up. All right. And so we did that by zeroing out the position register, and then in the Z position we stuck in minus 50. And so then we go in our program here, we do this motion where you could do a linear here, it's not that big of a deal, or you do a joint. Notice I did a continue. So remember, the continuation termination says don't stop. So we just kind of come in smoothly and line up. So we're coming in here, here's the cup, and we're coming up above it there, and we're just lining up, and then boom, we're coming straight down. We stop, we close the gripper. All right, but now with this coffee cup, definitely has a crazy moment of inertia on it, right? So now we got to change our payload. So we close the gripper, we wait a fraction of a second, okay, 200 milliseconds, and then we change to the payload of the gripper and the coffee cup together, okay? Then we're going to pull straight back out, so it's a linear move again. So we're pulling straight back out from where we were, okay, which was 0.2, and we're going back to that offset. If you needed to or whatever, because your coffee pot's so much longer, maybe I need a second offset. Could be position register 2 with a minus 200 or 400 offset or whatever it needs, on there. So it doesn't have to be the same offset. Okay, but I'm doing a tool offset again, but I'm doing a termination of a continuous 5 because I don't need to stop out here. I can just move it to wherever I want, right? Which is to my mouth so I can have a drink of coffee. Wow, good stuff. All right. So, but this is what we need to do when we're picking stuff up with grippers, or really the same thing when you're setting it down. So you need to come straight down to wherever straight is, depending on your angle or whatever. But that's where the tool offset is so beautiful for this application. Okay. All right. So I've been talking here a while. Is there any questions? Okay. So you're laughing about me taking my drink of coffee, I assume? Okay. All right. So anyhow, so that is, let's see. Wow, it's almost 2 o'clock here. But that is the bulk of the I/O. So you'll definitely want to review this. I've got this code and the slides. I think also I had it in the slides from before spring break too. But this code here, anytime you're picking something up, this is the code I'm pretty much looking for. If you're picking it up and then you're setting it down, all that. Okay. All right, so another thing to kind of talk about here, though, with these is that if you're going to set it down, okay, so this is the object of picking it up. Okay, so if we're going to set it down, you would still kind of, this part of the code here would not change. Okay, and I guess this code wouldn't change too much, but to set it down, you would move over to 0.3. There's something. Let's call this 0.3. Okay, I'm just going to try to. 3 is way too small. Okay, so we're going to go to 0.3 is the point that we're going to set it down at. Okay, so we're going to set it down at 0.3. Okay, so we got 0.3 here is where we're going to set it down. So we can move over to 0.3. That's where we're going to set it down. Oops, that's a big one. Okay, and then, so when we move over to 0.3 to set the coffee pod down or take it to your mouth to take a drink or whatever, however you're doing that, but we're going to take this. Okay, so this would now be 0.3. So the same thing, you still have your tool offset. Okay, so you're still going to have the tool offset piece over here. So you're going to come over and you're going to be up above where it's going to go based on that tool offset. And then you're going to come straight down to 0.3, right? But now we're going to turn this gripper off, right? So you're going to turn your gripper off. Okay, so instead of being on, you're going to turn the gripper off. And you're still going to wait. You're going to wait your 2 seconds. All right. But now, you got to return back to payload 1. Oops. Okay, so you're not going to do payload 2. You're returning back to payload 1, which is the gripper only. Okay, so we come to the part, point 3, we come to point 3 above point 3, right? So this line here is above point 3 by whatever the offset is, and then we come straight down to point 3, we stop, we release the part, we turn the gripper off, we wait again because it takes a fraction of a second for it to actually operate. Okay, but you could do a whole second, but I'm telling you, if we were actually watching it, you're sitting there waiting. Why is it sitting there so long? Okay, so you don't want to do a whole second. But then we reset our payload back to the gripper only payload, and then we need to lift a lift the gripper. We need to lift that gripper right back up, straight out again, because those fingers, especially if it's a finger gripper or whatever, you need to make sure you're clearing it. So we need to, we need to make sure we come straight out so it's linear with a tool offset. Okay, but and then we go on and pick up the next piece or whatever. Okay, so but that's, the big difference there is simply that we're going to turn our gripper off here, and we're going to return back to the gripper only payload. Okay, so those are the key items for the gripper, for picking up and setting things down and using these offsets. Okay, however, one other thing is, let's say that you're actually palletizing. So you're going over to a conveyor and you're picking up your coffee cup, but then you're going to go back and you're going to, let's say you're going to, you're producing coffee cups. So they're coming down the line and you're going to then pick them up and put them on a pallet and stack them. Okay, so then when you start stacking them now, you're going to have your set down point. Remember, point 3 is where we're putting it down. So the first time we put the first one on there, I don't know if I don't really have any objects in here that I took all my, I had my Jenga blocks in here and I took them to school before spring break. So I don't have my Jenga blocks, but so you have these and you're going to stack them, and every time you stack them, point 3 is going up, right? So point 3 now goes up, and that's where the offset itself goes. So so now we got our tool offset, but now as we're stacking these, we also need another offset. So I'm just try to make some modifications of the code here. So I'm gonna, this was my offset for that, but now I'm going to come in here and I'm going to go to point 3. So I'm going to use, say, position register 3. All right, so now position register 3 is just going to be a straight offset. So there we're just going to have offset. Okay, so, and we can add that right over here. We can have offset. Position register 3. Okay, so we have this extra piece here. I'm just going to draw a little box around this. I'll make it kind of thin. So we have this extra piece here for this offset. Okay, and what we're going to do is we're going to add this option onto the tool offset, because now we're stacking these. Okay, and so we have to do these, and so now this is an offset, so it shouldn't be a -50. It should be some positive value, and it's probably not 50, depending on how tall your coffee cup or Jenga block or whatever it is that you're stacking is. It may, if it's a Jenga block, it's only going to be like a plus 12 or something. Okay, and so you're going to have this. Okay, so you would zero this out, and then you would have a line here. You know, you would have a line here which would actually be doing a plus 12 instead of a minus 50 sort of thing. So it would be a plus 12, and that would be register 3. All right, so it's register 3, and we're still doing the Z because we're going up. If you're on a pallet, you probably may also have to have some X and Y's, and then you'll have to be changing them every time. Right, but so I'm just kind of showing that one part now, but this is going to give you your position register with a plus Z, and that's for these offset pieces, and you're going to have this offset for all 3 points. So you have a tool offset, you have the tool offset for the part above the object, but you also have your offset. You had to go up further, or maybe left or right, depending on, you know, if you're stacking it. You may even have a rotate in there, and so you have but that offset goes with all 3 of these instructions. Okay, so hopefully you guys can see all that pretty well on your screen. I don't know why PowerPoint doesn't let me edit. It'd be quicker and easier, I think, to edit in PowerPoint, but okay, so so that is like I say, for setting them down, especially like palletizing, you're going to have both this tool offset piece and the user frame offset, right? So offset by itself is user frame, tool offset is tool frame. Okay, and again, the tool offset minus Z is up above it. Offset is user frame, so plus Z would be up above your user frame. This is assuming your user frame is where you're setting them down, you have a flat user frame defined. Okay, so, you know, way back in, what was it, chapter 6, or when did we do frames? Frames was chapter 10, I guess, but way back in chapter 10 we did frames. Okay. All right. I haven't got to macros yet, but you know, it's been like over 2 hours here, so I think what I'll do is I'll get into the macros and the other miscellaneous commands on Wednesday. Does that sound okay to everybody? And so I think we'll just call it quits here. Has anybody got any questions? You want to type it in or something if you have any questions. All right, so this should have been recorded here, so if you want to go back and kind of rewatch it, hopefully it'll be saved in there and you should be able to access it. Okay. So, yeah, Austin, I forget, you're doing some sort of palletizing. I forget exactly whose project was what. That's the other thing. Let me just mention very quickly here on the project. Be kind of thinking about the project. I know some of you kind of already had a pretty good idea of what you were doing. But, you know, for pretty much everybody, I expect you to be picking something up and setting it back down somewhere to some degree. So this code, you know, you definitely should be using this code probably for your project. Like I say, if this virus thing, keeps us off campus for more than 3 weeks, um, we could probably be okay with 4. But if it goes beyond that, then I guess we'll just kind of have to use the simulation software, and I can make that software available, either download. It's kind of a big program. It's pretty large, so if you don't have good internet bandwidth or something, I may like burn it to a CD, and then if I have to, I'll mail it to you or whatever to get it to you. But it does require that. But then you could just do something along this lines inside the RoboGuide software and stuff. So, but we'll but think about that. And we will do macros. And miscellaneous stuff on Wednesday. And then next week I'll be having the exam. I'll just put the exam in Blackboard. And I believe I also mentioned in the announcement I sent out the other day that I'm also going to kind of give you a makeup exam. So we'll have like 3 exams, and I'm going to drop the lowest of the 3. Okay, so I'll kind of give you a attempt. Some of you weren't too happy with your first exam scores, so that'll give you a chance maybe to improve on that. So, but we'll talk more about that later. Okay, so glad everybody was able to connect today, and hopefully you'll be able to connect on Wednesday also, and just read through the book, read through the slides, rewatch this video, email me if you have any questions, or if you want me to call you, email me your telephone number, and we can talk over the phone or something if you need to. So I'll look to be hearing you from there. Okay. All right, so talk to you all later.